So in this part, we are going to perform a breadth first search using the Python code, and let's go do it now. In the previous class, we told you that you need to use the adjacency list to perform breadth first search, meaning that you don't have this actual tree visualized. Of course, you can't grab this picture and put it right into Python. So we need the adjacency list. So what I would like us to do now, let me hide this tree and let's use the adjacency list to perform the breadth first search of this tree and see if we are going to get it right. So this is the adjacency list we got from the previous lesson. So we printed it out using the tree. So I'm going to do now, I'm going to clean all of this and let's see. Okay, so let's go. So let's use this now. So let's start from the root. So the root here is G. So let's put it right into the queue, G, and we add it to the visited node G because I already explained this to you. We look at G, it has children C and I, so we put them into the queue, and of course when we move G from the queue to the visited node, we are going to pop it from the queue into here. Okay, so we go to the next item on the queue, which is C. All right, so we go to look for C. C have children B and E, so we're going to put them right here, B and E, and we're going to pop C from the queue and put it right here. So we have GC. The next item on the queue is I. So we go look for I in the adjacency list and it has children H and J. So we're going to put H and J here and pop I from the queue and put it here, I. We go to the next item on the queue, which is B, all right? So B on the adjacency list has a child A. So we dequeue, actually I mixed up pop and the queue. So we dequeue B from the queue and put it onto the put it onto the visited nodes. So actually, theoretically, you need to dequeue first and then put it right here. Okay, so have that in mind. So we look for the next item, which is E. E has children D and F, as you can see right here, these two children here. And we dequeue E and put it onto the visited node. We go to H. H, we visit it and it has no child, so we just put it here. J has child K, so we put it here and we dequeue it and put it right here. A has child none, so we dequeue and put it right here. And the next one is D. D has no child, so we dequeue and put it here. F does not have any child, so we dequeue it and put it here. And K does not have any child, so we dequeue and put it here. So we've generated this list of BFS nodes, okay, using only the adjacency list without actually seeing the tree visualized. So let's now reveal the tree and see if we got it right. So we have G here, G. On the level 1, level 0, we have CI, we have BEHJ, BEHJ, and we have ADFK. All right, so we can see that once we have the adjacency list, we can simply generate the breadth first traversal of the tree. So let's go and write the code that's going to use the adjacency list. We already created adjacency list here. We have this code to generate adjacency list and we have this adjacency list. Let's now write the breadth first search code to use the adjacency list and print out the BFS of this tree. Remember, BFS is not the same as pre-order, in-order, and post-order. These are two different things altogether. So we are talking about breadth first search. So I'm going to create a function. I'm going to call this function BFS. And it's going to take the adjacency list, let's call it AL, like this, all right? Okay, let me just increase the font a little bit. Okay, good. Now, we need two things. One, we need a queue and we need a list, all right? So the queue, I'm going to create a new queue. Queue is equal to collections queue. And I'm going to add the root because you always have to start with the root, all right? And I also need to create a list. I'm going to call it visited, and it's going to be an empty list for now, all right? Okay, so I'm going to now iterate while queue because we are iterating the queue. So while the queue is not empty, I'm going to say while queue is not empty is the same as while queue or while something is in the queue. What we are going to do is to extract the item from the queue first. So let's get the item for the queue. I'm going to call it node is equal to queue.popleft is going to retrieve the item from the queue. Now this item we retrieved from the queue, let me just kind of reveal this place. So once we get this item from the queue, we now have a list of items which is the values for this node or the children for this node. So we are going to, this node, we are going to add it to the visited list, right? And then we are going to add the children of this node, which is the C and I, to the queue. So first, let's add the node to the visited list. So I'm going to say visited. Visited is going to be visited. So why do we have this error here? Reformat file. Okay. Oh, okay. Perfect. It's good. So visited dot append, and what are we appending? I'm going to append node. Because that's a node we extracted, we simply append it. Now I'm going to use either a for loop to iterate through this list here, which actually contains two items, and append and add these two items in this list to the queue. I recommend using list comprehension to do it. So I'm going to use list comprehension to do it. Look at the description box, you'll see a link to learn a bit about list comprehension. So I'm going to say for every item in the list, for X in the adjacency list of the node, right? Yeah. So let me get it right. So sorry, I think I'm getting it a bit wrong. So I'm going to say QE.append X for X in AL of the node we extracted. I hope this is not too confusing for you. I'm going to maybe redo it using a loop, but for now this is fine. So Q.append X for X in adjacent and the list of the node. So we are simply taking everything here and adding it onto the queue. Okay, so let's see what next we have to do here. So basically we are done. So at the end of the day, everything should be done. So while there's something in the queue, pop it, add it to the visited node, and then add the children to the queue. All right, so what are we going to return here? We are going to simply return visited, all right? So basically that is it. But let's actually check if this works. So I'm going to remove this print statement here because for now we don't need it. So I'm going to call BFS. Actually, instead of returning it, I'm going to let's just print it out, and I think that will be fine. So let's print it out here. All right, so yeah, so let's call BFS a list. Okay, so I'm calling BFS now. I'm going to clear the console and I'm going to run the code. Let's see. So we have an output and we can see that it actually printed the breakfast search GCIBEHJADFK, as you can see. So we've completed this part. We've actually written a code to perform the BFS of a binary tree. The assignment I'm going to give you now is, instead of using list comprehension, try to use a for loop. So you're going to say for X in AL.node. So I'm going to just take out this. Let me just write it for you. For X in AL.node, we are going to simply say q.appends x. So this is gonna give us, I think, exactly the same result. So if I run it now, it gives us exactly the same result. But I recommend using list comprehension. List comprehension is far more easier to use than always writing a for loop. So let's check what we have next. For the next class, we have depth first search. That's another interesting one. I'm going to stop here. Please remember to subscribe to my channel and also leave me a comment if this has been informative for you.